another tutorial on MATLAB. In this tutorial series, we are looking into the concept related to the hybrid and electric vehicles. So first of all, in the videos, we are building up the conceptual understanding, and later on, we will go in a deep dive for the implementation related to different components in MATLAB and Simulink environment. In this particular tutorial, we will be looking into the concept of series hybrid architecture. We will also discuss what are the advantages, disadvantages related to the series hybrid architecture. So let's get started with the same. So as you can see here, you have a complete hybrid electric vehicle with multiple components. So the first component that you see is the engine. So engine is placed at then you will have a generator. So this generator will provide the power to the converters or the controller. So basically the controller converts or level up the requirement to the electric motor and also for the battery. As you already know, battery is a DC power source. Over here you can charge the battery with the help of a DC power source only. You cannot charge a battery with a AC power. Along with that, whatever the generated power that you are getting, so that you cannot directly provide to the motor, maybe the power level that the generator is being producing, right, will be little low, because as you know, the size of the generator is small. Along with that, maybe it will be producing based on the engine RPM. So how much voltage or at what frequency it is producing the output source, that is dependent on the engine. In this case, what is the advantage is the engine can run at optimum speed. So for engine, the torque speed characteristic will be more efficient in the higher speed range. So because of that, if you use the engine in a efficient way, then you can run it with a high efficiency, and then you will generate the energy through the generator without having much loss. So once you do rotate this generator, then you will be producing AC power source, and this AC power source will be transmitted to this converter or the controller. So it has two functionality. One is to charge the back, another is to drive the motor. Also along with that, suppose if you want to run on the electric mode only, so definitely this runs with the help of the electric motor only, but there are two possible power flow over here. Either the power will flow from the engine, or the power flow starts with the battery. So there are three modes possible over here. Either you can run with the help of the engine only. So at that moment, suppose the torque demand or the power demand on the driver side is very high. So in that case, you cannot charge the battery. So the entire power is being used with the help of this engine to the generator, and from the generator to the controller, from the controller directly to the motor. So there is no other power flow possible over here. Now suppose the driver is not demanding very high power, then in that case what should happen? So suppose you have the electric, you have the engine, it will generate the power through the generator. Now here there is two flow. One is to the controller, again from the controller to the motor. Along with that, what you can also have, you can charge the battery with the help of this controller. Okay, so the power flow will be controlled, then it will charge the battery. So this is possible in this mode. Suppose the power demand is very low or moderate, and you don't want to use the IC engine. You have a good percentage of the battery available, like suppose you are at 100% in the battery. So maybe you want to save some of the fuel that you have and don't want to use the engine at the same time. And suppose in some situation where you do need moderate amount of torque, then in that case you can use the battery only. How the power flow will happen in this case? Only battery mode. So in this case, it will start from the battery and it will go to the converter. It will drive the motor. So these are the three categories that are available in the power flow area. And what is the advantages that you are getting in this one is you can be like flexible. You do not need to run the engine with respect to the wheels or with respect to the demand of the driver. You can run the engine at the most efficient way at the optimum level. There will be very less loss in case of engine. Along with that, when you park the vehicle, suppose you want to charge your battery, so that is also possible. So while parking or while the vehicle is at stationary position, you can do charge the battery, and later on when it is needed you can use the energy from the battery. And suppose you are having some moderate amount of energy demand. In this case, you use only the battery. Don't use the engine. That way you will save some fuel in the hybrid electric vehicle. Suppose the power demand is very high. Now the demand is more. I need to maybe climb up the hill. So torque is needed more. So in that case, what can be done? Both the power source, the battery and the engine will provide the power, and that way you will meet the torque demand. And here, regenerative braking is also possible. So when you do regenerative braking, the main job of this controller is to also charge the battery, right? So in this case, the power will come out from the motor, okay, and it will go inside the battery with the help of this controller. So power flow will start from the motor and then it will go to the controller and then it will go to the, so battery will charge up. Because of this, mostly the vehicle battery SOC will be controlled with the help of the operation of the engine. So battery also you can have at optimum performance, right? So you will not overcharge the battery or you will not over discharge the battery. You will maintain a optimum SOC level for the battery. So that is one more advantage that you will get. So with this electric vehicle, you can optimize your engine, along with that your battery, if you do have a good controller which will also control all the output devices like an electric motor. So this saves a lot of cost and increase the range of the vehicle with the same amount of fuel that you pulse. So because of this, series hybrid has a good advantage. But as you can see, there are many power conversion happening over here. So you are producing the mechanical energy, and from the mechanical energy of the engine, right, you are generating electrical energy. So here the energy is being converted from mechanical to electrical. Again, you are transferring and leveling up the voltage or changing the current, something like that, the manipulation of the source in the controller. And there you will have switching losses as you need to convert it, right? So at that moment you will have switching losses. So that is additional loss. And along with that, again, you are driving the electric motor, and that electric motor is providing you the mechanical energy. So now again, the energy is converted from electrical to mechanical, helps driving the vehicle. So this architecture is efficient and also not efficient compared to like when we see the power conversion process. But yeah, so we need to know about the series architecture. So that's why we covered a little bit detail on the same, so that you will have a better understanding on the series. In case you are liking the channel, please consider subscribing. In case you have any comment or query, please let us know in the comment section. In case you have any new topic that you can suggest us to see the content in detail, please let us know as well on the same. Happy learning MATLAB. Stay connected. Thank you.